Okay, so for this slide here, we're going to be counting factors, especially underneath the radical. So 5 underneath the radical only has a power of 1. So the 5 is going to stay. So first things first, I draw my radical, 5. And the 5 goes underneath. So I have the fifth root of 5. Then I look at a. And a has the power of 5. So then I take 5 and I divide it by our index, which is 5, and I know I've got a 1. So a to the first stays out in front. Then you've got b to the ninth. B to the ninth, so we take 9 divided by 5. 9 divided by 5 is 1, so b to the first is going to come out. The remainder from that is 4, so we've got b to the fourth staying behind. Then we take c to the 13th. Well, 13 divided by 5 is 2, so c squared comes out in front. And then the leftovers would be c to the third, because the remainder from that would be 3. So you have ab c squared, fifth root of 5, b to the fourth, c to the third. All right. Now for b here, it's similar in a lot of ways. We take cubed root of x, and we separate cube root of y to the seventh. Well, cube root of x has a power of 1. I can't do anything with that. But cube root of y to the seventh, I take 7 divided by 3 is 2. So I go, oh, y squared is going to come out. Then I have the cube root of y, and over top the cube root of x. Now here's the issue. Normally with square roots, we just multiply by the same square root in order to rationalize the denominator. But now we need 3 versions of y underneath the radical. So in order to do that, I've got y to the first, so I need this exponent underneath to be a 3. So when I multiply and rationalize the denominator, I need the cube root of y squared and the cube root of y squared, not just the cube root of y. Because once I multiply these two things, here and here, they're going to end up with a y to the third. And so you have to make sure you account for that. So my new answer then is the cube root of x y squared all over y squared times my y now, because I ended up with the cube. Well, I'll write it. We'll have the cube root of y cubed. Well, the cube root of y cubed is y, so we simplify cube root of x y squared over y squared times y, which equals the cube root of x y squared all over y cubed. Okay? But the key was, when I go to rationalize, I look and I say, well, there's one exponent there. And it's, the 1 is the exponent there. I need that exponent to be a 3. Because I've got a 3 in the index. So I take the cube root of whatever would get that to be a 3 and multiply it, top and bottom. Okay, so y squared times y to the first is y cubed. So I have the cube root of y squared multiplied. All right, that's rationalizing when it's not a normal square root. All right, so here we're going to perform some operations. We have 5 root y plus 6 root y. Again, what we basically have is a root y distributed to the 5 and the 6. So I can factor that root y out, leaving 5 plus 6 in parentheses, which is 11. So we end up with 11 root y. All right. 2x y to the 1/3 minus 7x y to the 1/3. Again, we have this y to the 1/3 that's distributed, and we need to factor that out. So we have y to the 1/3 times 2x minus 7x, which equals negative 5x y to the 1/3. Okay. And then looking below here, we want to try to simplify things as best we can. Well, 5 to the first isn't going to give me anything. This 5 right here is not going to give me anything out of that cube, so there's nothing to simplify there. But 40 is a factor of 8 and 5. Or, excuse me, has factors of 8 and 5. So what we could say is the cube root of 8 is 3, because it's 2 to the third. So I can pull a 3 out. So I'm going to rewrite this thing. I'm going to go, all right, well, in this part here, we've got minus 2x cube root of 5x squared. Now you're asking, okay, well, what about x squared? Can we do anything there? Well, look, it only has x and x. It does not have, see, we've got x squared. 2 divided by 3 does not divide evenly, so the x squared can't come out. Then in our first part here, we have x to the 5th and a third index, so I can take 5 divided by 3, I get a 1, so I know I can pull at least one x out, x to the 1st, and I still have my 3 out in front. Then I've got the cube root of 5 and the leftovers, which is x squared. Okay, that's the remainder from 5 divided by 3. All right. And now what we've got is we've got a cube root of 5x squared that's being distributed to both parts. So I can say, all right, well, the cube root of 5x squared times 3x minus 2x, which equals x cube root of 5x squared. Okay? So keeping in mind these kind of problems here, you're looking for something that you can eventually factor out. So once I simplify either of my radicals as far as I can, most likely I'm looking to simplify the other radical just as far to the same thing. Right? I wanted this 5x squared here and this 5x squared there, so that when I factor it out, it's actually factorable, because they have to be the same number in order to factor it out. Alright, so these problems here are just for you to do some practice if you so choose. I would at least try the odds. We can practice some of these in class. But go ahead and use these for any sort of practice to make sure you understand what's going on. If you want to bring them to me, you're more than welcome to. Thank you.